Alright, so in this video I wanted to take you through the LangChain's input-output module, which can help us to do several tasks like templatize the prompt. We can switch between different types of LLMs using this module, and also we can parse the model output according to our desired format. So let's go through each of these things and how we can do it using LangChain. First of all, few of the installation which I am doing, which are required. So the first three is like we are using the Llama2 as one of the models. So we will try to load the Llama2 in a quantized manner. So this first three libraries will kind of helps us. Then we will use transformer. TRL is not required, but still I am installing it. Then the last one is LangChain, right? Uh, then few of the imports which are related to like importing numpy pandas and just suppressing the warnings, because like some of the warnings which are frequently comes from LangChain, that we will suppress using this command. And then I'm using this Amazon mobile review dataset, so we will fetch few of the rows from this dataset and we will use it in our coding purpose. Then I'm just dropping when there is a null record present. Then few of the important libraries which are I'm importing in this section, like torch transformers. Then I'm using the Hugging Face pipeline, then the prompt template or the LLM chain, which will help us to create the prompt template and also chain the prompt and the LLM in a single interface. Then we have the token auto tokenizer and auto model for causal LLM. This is we will use to load the Llama2 model. So as I'm using the Llama2, so I need to log into the Hugging Face model hub. So this is, once you run this code, it will ask you for the password or the token. So you can go to this Hugging Face page, and from the settings, if you come to this access token part, and then you can copy this password and paste it in this section of your notebook, and it will kind of enable you to load the models from the Hugging Face model hub. Then I'm using the Llama2 chat version, and I'm just creating the tokenizer and also importing the pre-trained model. And so this process takes around 23 minutes. So if you are seeing that this is taking a lot of time, just be patient, and once it is done, then you can start then you can start doing the downstream task, right? So later on we will also see how we can incorporate PaLM2, and PaLM2 model loading process is much more faster. So in the future videos I will use PaLM2 to do the downstream task using LangChain. So first of all, I am just creating a Hugging Face pipeline where I am passing my model, the tokenizer, and few of the model parameters. And so the details which you need to understand is also I have made a video on what is this top K and temperature. So you can refer this video to get an understanding of that. Then I'm just selecting a random prompt, and I'm running to see how the model output looks like, right? So my prompt is like, hi, I'm learning data science, can you suggest me top 5 things to learn, right? Then this is the output which looks like. So output, which we can see the top 5 things it has pointed out in this LLM output. So the outputs are not well formatted, so we will use different techniques of LangChain to format the output. And also the skill which we are using here, like data science is one of the skill, right? So you may want to like make this prompt much more flexible and make this skill as kind of a user input which user passes, and based on that the LLM produces the output, right? So let's talk into that how we can do this two things, like uh, making the prompt much more flexible, and also how we can format the output in much better way, right? So to start with, we will do certain like groundwork, like we will import the we have already imported the Llama2 model, and we will use the Llama2 prompt template to create the prompts. So this is how it looks like. So this is how the prompt template looks like. It starts with inst, then the system prompt. The default system prompt is been that you can see in the screen. That is a default system prompt from Llama 2. Then we have the user instruction, and we have an ending tag of inst or the instruction, right? So this is where I am just writing a function to get prompt template, which will take the user instruction, and also if you want to change the system prompt, so that also you can do using this function. So default value I am using is the default system prompt. Then I'm building a prompt template, and I am writing a instruction here. Hi, I am learning. So I have, you can see like I have made the prompt much more flexible and adding the skill as a variable to this instruction. Then I'm asking, can you suggest me the top 5 things to learn, right? So then what I will do is I will pass this instruction to this get prompt template, and I will get the template. So at first there is a default system prompt, then the user instruction which is coming up here, right? So after that what we can do is we can use this prompt template. So this prompt template will enable us to use skill as an input variable. So you can see I am mentioning the template here, and also I am mentioning that the input variable is nothing but skill, right? And then you can print the prompt. So the prompt along with the default system prompt is coming up here. So you can also see that if I just do this prompt dot input variables, it splits out that skill is the input variable that the user needs to give when calling a LLM with this prompt, right? Then slowly we will talk about what is chains. So next video will be much more detailed in terms of chains, but here we are also using chain. So chain is kind of a thing which allows us to combine multiple components together in a single coherent application, right? So here what I am doing is I am creating a LLM model which is like using the Hugging Face pipeline. I am passing the previously created pipe or the pipeline. Then also I am passing certain model arguments, and then I am creating a LLM model. So that LLM model along with the prompt, I am just combining these two components and creating a chain using this LLM chain, and I am naming it as LLM underscore chain. So this LLM chain will kind of bind the model prompt, and it will pass the prompt to the model also to get fetch the output, right? So this is how the job is much more easier using a chain, and it will kind of it formats the prompt template and then passes the formatted response to the LLM, right? So then we can run this that LLM chain dot run. So whenever you are creating LLM chain to pass a prompt and get the output, you have to do this dot run function and then pass the input variables value, right? So the value is here data science. So I'm passing the data science and I'm just getting this output, right? So here you can see you have made your prompt much more flexible with the prompt template with the help of LangChain. Now you can just change this value to data engineering, and you will get the top 5 skills you need to learn for learning data engineering, right? So the prompt template which gives you the flexibility of using any of the user input, and based on that the LLM will produce the output, right? So now we have made the input and the prompt is flexible, but the output is still looking messy, right? It is still not well formatted, which we can use it for the downstream task. So let's work on this output, and using the another component of LangChain, which is output parser, we will try to format the LLM output in much better way, right? So there are few certain steps which you need to follow to create output parser. First is you define the response schema to format the output with specific attributes and data types. So first of all, you need to create a response schema where you need to mention what are the attributes you want to have in your output and what are the data types corresponding to those attributes, right? So once you create the response schema, then the second steps comes where you create an output parser by passing the response schema to the structured output parser, right? So this is like structured output parser takes in the input as response schema, and it creates an output parser, right? And the third step is you will create a format instructions which we will be passing to the prompt template, and we will instruct the LLM using this format instruction to format the output, right? So these three things we need to create at first, then we can do a then we can pass a prompt to LLM to get the output. The first one is response schema, then we will create a structured output parser, then we will create a format instruction which we will pass to the prompt template, right? So here you can see at first I am creating a format schema where I am mentioning that um, the two attributes which I need to have in my output is sentiment class and also the probability, right? So I am also giving a description for each of these attributes, like the sentiment of the given text, and for the second attribute I am mentioning the description should be probability value of the predicted class. So we are asking LLM to do a sentiment classification task, and we are asking it to give two outputs. One of them is like sentiment class, and the second one is the associated probability with that sentiment class, right? So once I have defined the response schema, then what we will do is we will go ahead with the second step, where we will create an output parser by passing the previously created response schema into the structured output parser, right? So all these things you also need to import here, right? And so once you do that, you will create the output parser, and you will have we will create the output parser with the help of the response schema. So what I am doing is structured output parser dot from response schema, and I am passing the response schema here to get the output parser. So once you have created the output parser, now the third step, where you will create the format instructions, right? So what we will do, you will do is output parser dot get format instructions, which will fetch you the format instruction, and this format instruction we will pass as an input to the prompt, right? So the three steps again, like the first one is like the response schema which we are creating here, then the output parser, and the last one is the format instructions which we are creating here, right? So with that you can see, the if I just print the format instruction, it shows you the structure of the output, right? The sentiment class and the probability. It also tells you that the sentiment class is string and the probability is also string. So this you might get concerned that probability is still string, and it is not. It should be either float or integer, right? So we will see how we can tackle this problem of assigning particular data type to attribute, right? Then we will create the instruction. So instruction is extract the sentiment from the following review, and I am just giving an input variable which is the text. Then I am asking format the output as JSON with the following keys, and I'm mentioning the sentiment class and probability. Then I'm giving the format instruction, right? So you can also try without giving this two attributes, and I hope that you will get the better results also, right? But just to be on the safer side, I am also mentioning what would be the two attributes which I need as an output from this LLM call, right? So then I am passing this format, then I am passing this instructions sentiment to the get prompt template, and I will get the template which is related to the sentiment classification. And this is how the output the prompt looks like, or the template looks like. So first is the default system prompt, then the user instruction, and then the user input also is mentioned here, and in the end we are also asking to format the output using this format instruction. Then we will create a prompt template. In the prompt template we will pass the template sentiment, then the input variable is nothing but the text, and also as a partial variable I am passing the format instruction as an input to the prompt template. So the prompt will now know what is the input variables and how also it should format the output which is being generated by the LLM, right? So this is how it looks like. And then I am creating a LLM, and using the previously discussed concept that we will create a LLM chain where I will pass my prompt along with the LLM, and we will create a LLM chain. right? So the dataset which we are using, the mobile review dataset, so I'm just randomly picking up a review and I'm creating a text variable with that string, and so I'm passing, then I'm calling the LLM chain with this text and getting the output. So you can see now the output is much more properly formatted, right, where we have sentiment class and also the associated probability. So it also gives you the explanation why the model thinks that it is giving a neutral as a sentiment class for this prediction. But if you just parse this output, you will only get this two things which we have mentioned in the format instruction, right? The sentiment class and associated probability with that. So after that, what we will do is we will kind of integrate this format instruction in a code. So before previously we were using this get prompt template. Now we are also using this another function which is get LLM chain. So in this LLM chain, what I am doing is I am passing the format instructions also, right? So based on the format instruction, it will format the prompt template, right? So at first I am checking if there is a value associated with format instruction or not. If there is value, then this will become true, and we will add this as a partial variable to my prompt template. Else we will not use anything and we will get the prompt as it is, right? Once we have the prompt, then we will create the LLM and we will pass the prompt along with the LLM to the LLM chain to get the final LLM chain. And using this function, I am just returning the LLM chain from this function, right? So this is kind of wrapping up the two things, like we are passing the format instruction and also creating the LLM chain using this format instruction, and then returning the LLM chain from this function, right? After that, I'm just doing a summarization task, just checking how the output will look like. So here I am creating an instruction that summarize the following review for me, and then I'm passing this instruction to this get LLM chain function which we just created above, and then we are creating the LLM chain. So as I am doing print statement using inside this function, which you can see here, just I'm printing the prompt. So the prompt will be printed as an output when we call this function, right? Then I am running this LLM chain dot run on the same text, and we are getting a summarized output of this input, right? Now few of the other examples which I wanted to show you is like these are all like mobile reviews, right? So using those reviews, we will try to identify if there is any battery issues that are mentioned by the user or not, and we are using LLM to find out those issues, right? So at first I am writing a battery issue instruction prompt instruction here, where I am mentioning examining the following review, which is review given by a customer for a mobile purchased. Please let us know if the following mobile review mentions about any battery issue or not, and I'm also mentioning the format instruction here, right? So this is where I'm mentioning the format instruction. Then I'm creating the response schema where I have two attributes which are like battery issue and reasoning, right? So it's not that your LLM is only mentioning that it thinks that there is a battery issue mentioned in the review, but it also tells what is the reason behind this particular answer for battery issue, right? Then I am creating an output parser, and then I'm creating a format instruction, right? So once we have this format instruction, then we can call our previously created get LLM chain function, where we will pass the format instruction and we will get the LLM chain. And then using those LLM chain, we can make predictions on 10 records from this data frame. And so if I just loop through this the 10 predictions, you will see the battery issues are, for the first example, that is mentioning that yes, there is a battery issue, and also the reasoning behind that. So it tells you that the reviewer mentions that phone's battery finally fell apart after 2.5 years. indicating that there might have been a battery issues, right? So it's giving you the also the corresponding reasoning behind those explanations. So you can just go through this each of these examples, and you will see in some of the cases it's mentioning that there is a battery issue which is present, right? Okay. So now what we will do is we will talk about this output parser error fix. So in some of the cases you will see that instead of using output parser, you are not able to parse the output. So there are two ways to fix this. So you can use this output fixing parser component from LangChain.output parsers, where you need to pass the parser along with the LLM, and it will try to fix the output. So once you get the new parser using this, then you again try to parse the output using this new parser.parse, and you pass your new output, right? And then you hope that your this output parser will fix the issue associated with the parsing error, right? Then you can also try with this retry with error output parser. Here you are kind of creating a retry parser, and with that retry parser you will pass the prompt also along with the output, right? So it is kind of, it will try to call the model again, and it will try to fix the parsing error using this mechanism of retry with error output parser, right? So here you will see, here we are passing prompt as one of the parameter to this call, but in case of output fixing parser we are not using the prompt anywhere. So it's kind of again you are calling the model along with the parser and the prompt, right? So I hope you got the understanding why we need to use output parser and how we can fix the errors associated with an output parser. So next I wanted to talk about was how we can switch between the models. So now we were still till this part we are using the Llama2. Now we can use the PaLM2 as a model. So in case you are not aware of PaLM2 and how to get the access of PaLM2, so I have a detailed video. So I will also mention that link of that video in the description of this video. So please refer to that in case you are not aware of how to use a PaLM2. So this is like a basic configuration stuff. We are just picking up this text bison model, and that model we will use for the downstream task. So I'm also writing a get completion output function where I am passing the model, the prompt, and also the associated temperature, right? Then this interesting thing where we will kind of use a Pydantic output parser where we will create a class, and inside those class we are specifically asking LLM to give the output in particular data type, right? So here if you see, we have imported this Pydantic output parser, and once we have imported that Pydantic output parser, we have also imported this base model, and this base model we will try to inherit and create a new class, and this is like the phone company info, which I'm naming this class as. We have two fields associated with this. One of them is like the data type is like string, and the other one is a list, right? And also I am mentioning the description of each of these attributes. The first one is like a name of a phone manufacturing company, and then the features are nothing but a Python list of 5 phones made by that company, right? Then I'm creating a Pydantic parser, which is like I'm passing this Pydantic object, which is nothing but the class as an parameter to this Pydantic output parser, and then we will create a format instruction. So once we have the format instruction using this Pydantic output parser, then we can create a prompt out of this, right? So here you can see all the details like how the output should be. So it requires, the required things are two, which is like name and feature associated. So then I'm creating a prompt template where I am passing the template as answer the user query. Then I am also mentioning the format instruction and also the query. The input variable is nothing but the query, and I am also passing the format instruction, which is nothing but a Pydantic parser, right? Pydantic parsers format instruction. And slowly we will create input or nothing but a prompt. So here I am mentioning the name of a phone manufacturing company is Samsung, and please let me know the list of phones of that company. So I'm asking to give me a list of phones manufactured by Samsung, right? Then I am using this get completion function, and I'm passing my prompt, and we are getting this output. So you can see the output is well formatted, where name is Samsung, and also the 5 phones that are being manufactured by Samsung is also given as an output, right? Then we will try to format this using this Pydantic parser, and you will see that the list and also the string is coming properly, and it is of the type of a class, right? So the type of this output is nothing but a class string, and now you can use this well structured, well formatted with defined data type. You can get the output and use it for the downstream task. So that's all I wanted to talk in this video. So this video was about using the model input output LangChain component, and how we can templatize the prompt, how we can switch between two models like Llama2 and PaLM2, and how we can also use the output parser to format the output of LangChain. And also the last thing which we talked about was the Pydantic parser, where we can define our specific data types along with the description of the output, which will give you kind of well formatted output, right? So with this I will end this video. I hope you like this one, and stay tuned for the future videos in this series of LangChain. Thank you all. Thanks for your time.